Hello everyone, my name is Lukas Bruell, and I'm part of the founding team of Nillion. At Nillion, we have spent the last 3 years focusing on leveraging new cryptographic primitives, leveraging new privacy technology, to create fundamentally new design space and infrastructure for the crypto space and beyond. Our mission is to create a fundamental new layer for the internet, a new layer that's focused on privacy, self-sovereignty, data security, and trust mitigation. The way we achieve that is by democratizing access to what we call privacy-enhancing technologies. These are technologies that make data private by default, all while making them commercially viable. All of this work has culminated in the creation of Nillion's blind computation network. Before I explain what we mean by blind computation and why it's so important, I would like to take a step back and look at how it fits into the crypto space as a whole and why it's so important, particularly in the crypto space. Crypto started with Bitcoin, right? Bitcoin's mission was to fundamentally eliminate trusted financial intermediaries, to create a decentralized, trustless, self-sovereign system for asset ownership that put us in control of our assets, right? Not your keys, not your coins. Ethereum then really took this principle a step further and created a system, a general purpose blockchain network that could handle data much more broadly beyond just Bitcoin transactions, right? So for the first time, we had a general purpose processing network that could handle data, non-sensitive public data, but all on the same principles: self-sovereignty, trustlessness, decentralization. And with that, we have seen the first really exciting applications: DeFi, gaming, prediction markets, and many others followed. And with that, blockchains themselves also got better and better. They get faster, more modular, more cost-effective, and we're still in the process of doing so with new technologies like CK pushing the scalability further. So really where we are today is we have the decentralization networks for financial assets. We also have that for public non-sensitive data, but we still are missing fundamental infrastructure that can do the same for very sensitive data. They can do the same for private data. They can do the same for what we call high-value data. And this is exactly where Nillion's blind computation network comes in. Blind computation enables you to store and process very sensitive data without anyone ever seeing your data. In other words, the network is blind. That's where the name comes from, blind computation. You can encrypt your data. You can send it to a decentralized network of nodes. You can then store the data and process the data without seeing anything about the underlying information, and then send back the output of that to a specified party. So really what it does is it dramatically extends the design space for trustlessness, for self-sovereignty and decentralization to a new category of data, and that data is high-value, sensitive personal information. Question is, why do we need that, right? It's probably a good question why we need that. Well, the reason why we need that is because today, when we process information, data is actually not securely handled. And it's not very private at all, which is something that maybe some people might not be thinking about. In this particular example, if you take a picture and you process that image in the cloud, whenever that image is processed, your data is actually not private at all. The data is fully exposed, which puts you in risk, which puts all of us at risk, because it means we have to trust a few very powerful companies with all of our data. We have to trust them that don't share it. We have to trust them that don't misuse it. And we have to trust them that don't exploit it. And above everything else, we have to trust them that third-party hackers can't get access to the information, such that they protect it. So the good question is now, shall we trust them? And I think the answer is probably overwhelmingly not, right? Probably not. Cybercrime costs us 9.5 trillion with a capital T, every single year. And it's not a question of whether we will get hacked. The question is, when do we get hacked? And the question is, how often do we get hacked? Backdoor access to data has also proven to be not the particularly viable option either. So with all of that in mind, I think it's very obvious why we need blind computation. Blind computation is a new paradigm of computing that puts you in control of your data. Rather than trusting one company, you can distribute the trust across multiple parties. You are in control of your data, and the data is always fully private throughout the entire life cycle. When you store the data, when you transfer it, but now also when you compute on it. What are the potential use cases of blind computation? Well, sensitive data is pretty much everywhere, right? Pretty much any industry is touching sensitive data the one way or the other. In other words, high-value data is everywhere. Let's take a look at AI. Every time we interact with AI models today, we may leak a lot of very sensitive personal information. Whenever we train those systems, whenever we run those systems during inference time. Which basically means we have to trust a few very powerful companies with all of that data, which is a big deal. We look at enterprises, for instance. They're dealing with very sensitive information. They're dealing with confidential information every single day. And if you look at us as retail users in an age of personalized AI, where we have our personalized agents that know us better than we know ourselves, with all our messages, our health records, the way we slept yesterday, our nutritional data, everything, it's very scary to think about a future where all of that data is controlled by one company, is controlled by one individual. Blind computation can help here because blind computation enables you to train models and to run inference on these models without anyone ever seeing anything about the underlying data, which really removes the trust assumption that you have in one company and makes a true self-sovereign AI future possible. But it's much more than AI. Let's take a look at healthcare. In healthcare today, data is very scattered. It's not interoperable, right? We have clinics, we have research institutions, data is everywhere. And at the same time, breaches with respect to healthcare data is happening constantly, which puts our most sensitive data at risk. Blind computation can help here because it can enable us to share data with each other in a fully privacy-preserving manner and enable us to find new discoveries like diagnostics, personalized medicine, population health management, all of that in a fully privacy-preserving manner. I want to pick one more, financial markets. We look at traditional finance in dark pools. Whenever we submit trading information, we have to trust financial institutions in not front-running that information symmetry. That's the reason why they get fined every single year, pretty much every single year, with tens of millions of dollars because they have been front-running that information. And on-chain, in the Web3 world, we see this every day. Massive amount of front-running, massive amount of MEV and tax that users have to pay that they might not be aware of or are aware of but don't know how to resolve. Blind computation can enable you to do effective trade execution in a fully privacy-preserving manner. You can send an encrypted trade to a network. They can run an order book algorithm or any other trade execution venue without seeing anything about the data and nonetheless generate trades. So these are just 3 examples out of many, many markets, but I think a good question is, these are all potential use cases. What have we seen so far on Nillion's blind computation network today? And the exciting news is we have seen a lot of very novel applications being built out on our network. Use cases that we have never seen in crypto before, which is incredibly exciting for us to see. For instance, in AI, we have seen things like decentralized weight aggregation in the context of federated learning, all being done in a fully privacy-preserving manner. In healthcare, we have seen genomics platforms that are essentially building out DNA platforms that can enable the analysis of very sensitive DNA information in a fully privacy-preserving manner. Another one I'm very excited about is the self-sovereign data sharing aspect, where we've seen a lot of platforms that enable you as a user to bring all of the data together into one place and then to enable cross-user analytics on that data and enable third parties to access insights from that data without ever seeing anything about the underlying user information. So those are just a few examples, but fundamentally what it comes down to is that data privacy and data security are of the essence, and it's very exciting to see that growth. Now, we see on this ecosystem chart, as I said, a lot of new novel applications. To take this now to the next stage, the next level, I'm very excited to announce that we are now in the process of integrating the Nillion blind computation network to blockchain networks. Which is really, really exciting, because fundamentally what that will enable is that any on-chain application today can seamlessly tap into the privacy superpower of blind computation. They can tap into the storage and the computation of sensitive data in a seamless way, which we believe will create a fundamental new wave and design space for applications in the crypto space. So with that in mind, the question is, what do we want to achieve here? What's the objective? The objective is that whenever an on-chain app wants to store or process private data, they can send a request to the Nillion network. The Nillion network then runs the computation in a fully privacy-preserving manner, and then sends back the output to the blockchain. We could also have scenarios where an application might not have any on-chain logic deployed, right? They go natively to the Nillion network, they run some confidential computing, but then they want to settle immutably, transparently, verifiably in a blockchain, which they can also do. In other words, Nillion's blind computation network will have read and write functionality to existing chains. And the three key design goals we have here is, first of all, a user experience as native as possible. Users should not have to download anything or switch networks. And third, users should be able to pay in the native blockchain's currency. What are the potential use cases for this? Why is this new design space? Why is this a new wave? Well, design space is massive, but a few that I'm very excited about are, for instance, things like private agents. Think of agents who need to tap into very personal, very private information to execute personalized tasks. They can tap into blind computation, run that computation, and then execute follow-up transactions and pay on the blockchain. Think of things like private healthcare implementation or private DeFi implementations. With private DeFi, for instance, you can now enable the trade execution to happen in a fully privacy-preserving manner and then settle on a blockchain transparently, verifiably. Think of private credit scoring. You will be able to evaluate credit scores based on on-chain and off-chain data in a fully privacy-preserving manner, which can really expand the design space for on-chain lending also into under-collateralized lending. Think of private game functionalities, where you can seamlessly tap into trustless randomness generation and shuffling for on-chain games. Or private social platforms, where your social graphs might be stored in a privacy-preserving manner, and you can analyze user preferences, personalized content, without ever leaking anything about the underlying user information. All of this is really exciting, and what's even more exciting for us is this is not just some futuristic thinking anymore, actually. We have spent the last months working really hard on the first blockchain integrations, and are currently in the last stages of the version 1 with an integration of the Near ecosystem. This will enable any application on the Near blockchain to tap into the storage and the blind computation of Nillion's blind computation network. And at the same time, unlock fundamentally new AI capabilities. New AI capabilities that will make privacy first, a user-owned, and self-sovereign future truly possible. I'm super excited about this. I'm super excited to see what people will build with that integration. And obviously, keep an eye out on the announcement in December. We're really excited to push that out with the first demo. In the meantime, if you guys are interested in learning more about Nillion, please follow us on Twitter, Nillion Network. Please follow us on Discord. If there's any builder in the room or watching online, please feel free to reach out. We'd love to hear from you, and we'd love to create fundamentally a new layer for internet, as I said before, a layer that's private, self-sovereign, and trust mitigated. Thank you very much. Thanks for joining. See you later. Thanks.